Topic today is vehicle tracking. When I made the proposal for this session, I was thinking what to do, and then I decided to go, let's say, I don't say from very beginning. What we will do, we will create vehicle based on some data sheets, and then I want to build on this more. So we will put some loads for analysis, reporting functionality. We will cover. I want to show you how to create a vehicle for animation. What I mean is that we can do some 3D blocks. We can put it, for example, for trailer. This is another goal. Another topic will be we will bring, for example, some vehicle created in 3ds Max, and we will bring it to vehicle tracking just to make a nice presentation vehicle. And I want also to cover roundabout junction, just to show you not only what is possible, but how it works, what are the settings, what you can expect out of it. We will cover layers and stuff like this. So in fact, the goal is to start from, let's say, easier parts, but build on this more and more information that you know what is really possible with vehicle tracking. So first, I would like to introduce myself. Well, I'm coming from Czech Republic, small country in the middle of Europe. And yeah, I put some pictures. You might know maybe some hockey players playing here in NHL, or some tennis players, beer maybe, whatever. So by the way, Czech Republic is known as the country with the highest consumption of beer per capita per year. That's life. What I'm doing, I'm working for Autodesk. In fact, I just celebrated 10 years in Autodesk, and I'm covering CHS and Poland. What does it mean? CHS is abbreviation or acronym for Czech, Slovak, Hungary, and Southeast Europe. Southeast Europe is Romania, Bulgaria, and in fact ex-Yugoslavia, and also Poland, with population 40 million. So in fact, I'm covering a region with more or less 120 million people population. And I am originally a land surveyor, but I'm working with, let's say, infrastructure designing software for more than 20 years. Scary number. In fact, before I joined Autodesk, I was working for reseller for Czech and Slovak and Hungary, and we were doing, by the way, also Savoy computing, because I don't know if you know, in fact, vehicle tracking is coming from acquisition, which we did in 2013, something like this. I just don't remember exactly when Autodesk acquired Savoy Computing, out of, well, you might still hear AutoTrack. So from AutoTrack, we created vehicle tracking, and so this is in fact our topic today. So I believe it's a good, let's say, introduction, and let's go to theory. Sorry. If you are talking about step path analysis, so it's based on Ackermann principle, basically, and in Wikipedia you can find that this is basically what is Ackermann principle is basically principle how the vehicles are turning, because of course inner and outer wheel has the different radiuses, so it has to be solved. So this is something which has been in fact invented quite a long time ago, and we are using this also in our software. What I would like to say is that it is for low speed vehicle movement. What does it mean is that we are not solving some dynamics with high speed, for example, rail or car driving. So basically it's for really low speed maneuvering. And So this is what is Ackermann principle about. Basically, you have inner and outer wheel, and you have to solve the issue that these wheels are not sliding. And within vehicle tracking, what we are doing, in fact, we are creating what we call spine vehicle. Basically, what we are doing is we are creating, theoretically, we are taking wheel in between both wheels on left and right hand side, and we are creating single effective steering angle, single effective front axle, and single effective rear axle. So this is basically theory behind. In fact, if you go on YouTube, you can see a lot of basically videos explaining this theory more in detail, just to give you some background what we are using, and of course now the topic during the session will be how we are using it and what we are doing with that. So, and there is, of course, some equation behind. So basically, what is important to create a vehicle, it is information about, in fact, not only to put information into this equation, but then we have also chassis, some rear overhang, where is the coupling and stuff like this. So this we will see during, let's say, vehicle creation. So in fact, the minimum what you need is wheelbase, maximum steering angle, and minimum turning radius. But as I said, to create vehicle which will be used later on for swept path analysis, it's much more complex, and you need more information to do that. Yep. So as I said, vehicle tracking, it's this I didn't say. In fact, vehicle tracking can run on different platforms. It can run on the top of AutoCAD. Or better said, it can run on the top of AutoCAD and other AutoCAD verticals, which means that you can use it in, for example, I'm sometimes doing presentation for plant customer using Plant 3D and vehicle tracking, but you can imagine you can use Map 3D. On the other hand, the biggest advantage or biggest benefit is with Civil 3D, because if we are talking about surfaces and if you want to work, of course, with alignment, profiles, with corridors, so then the biggest advantage is really with Civil 3D, and you will see it in fact mainly with roundabout, where again roundabout can be done only in 2D, but this is most probably not enough, maybe on some very preliminary stage of design, but then you want to create all other components like corridors, and then you want to use the swept path analysis on the top of that. So really the biggest advantage is using Civil 3D. And in fact, you can also install vehicle tracking on the top of MicroStation. Yep. So using vehicle tracking, we have in fact two different settings, system settings and drawing settings. And now I will not really go to this deeply, because you will see later on why I'm using vehicle tracking. I will refer and I will show you which settings are important and necessary for different parts of design or using vehicle tracking. But what I want to stress is this is really important to understand these settings while working, because sometimes you are doing something and then where it is, what's going on, is it in correct layer and stuff like this. So everything is set here in these settings. And in fact, mostly you will be using, I believe, drawing settings. So just maybe time to switch a little bit. So if we are talking about vehicle tracking, after installation of vehicle tracking, you have new ribbons. So and basically what I will be using mostly these ribbons which are related to vehicle tracking, and I will use it on the top of Civil 3D, just that you understand. Talking about settings, so I was referring to settings, so basically here you can see system settings and drawing settings. And opening it, so you will see, in fact, here two different, let's say, subnodes, one for swap path analysis and one for junction. Yeah. On the other hand, there is talking about vehicle tracking. There are basically three main parts. One part is related to swap path analysis, one part is related to parking, and another part is related to junction, or, well, I'm referring it to as a roundabout settings. So with that, let's move here. And so let's talk about vehicle library. So there is, after installation of vehicle tracking, there is, in fact, a rich library of vehicles which are available. And in fact, this library is, these vehicles are in fact logged, you know, so you can see some red log pad here. So you can use them. You can copy and edit copy, but you cannot you cannot edit this, let's say, original vehicles which are supplied with software. But what we will do is we will, based on these vehicles, we will create a new vehicle which will be related only to our current drawing, and system in this case is creating some pool of the vehicles, and this pool you can see here, it is not logged, so basically I can edit them, but as soon as I have there some green log pad, this is logged for current drawing, and the reason for this is because this vehicle is already used within the drawing, so you cannot edit the source information. So again, either you can delete this path and recreate it with edited parameters, or again you can edit a copy. So, and the library is divided, or some hierarchy, so group, vehicles, and separate units. But again, you will see it during the live presentation. So what I prepared for this first part is the first, let's say, easy exercise will be, we will combine existing units, and I will show you how to work with the library, vehicle library. Then we will create fresh new vehicle based on data sheets, and then I will cover rear steering if you have some large trailers and you want to basically specify the rear steering for the bogie at the end, you know, so we can do all this stuff as well. So, and combining unit, I was just thinking what to start with. So what we will do, I know that here in US people are using quite a lot of these recreation vehicles, and what the goal of this short exercise is, we will use something, some bus, which we will use as a first unit, and we will add another unit, another on the drawbar. There will be this bus will be towing some passenger car. So with that, let's go and let's have a look what you can do with software. Here is, as I said, vehicle tracking. So let's go to Vehicle Library Explorer. And what I will do at the beginning, I will start with European vehicles, and I will use, and yeah, I know I'm European, sorry, I will be using meter units, yeah? Sorry for that, because it's a bit more understandable for me. So let's do this. So as I said, here you have a log pad. So basically, I can view it, but I cannot edit it. I can only edit a copy. So with that, let's do this. Or maybe let's do it different way. So I can immediately drive. So I will use we have different modes. I will use auto drive arc, and I will not make it as a default vehicle, and I can drive it. Yeah. So what will happen is I can drive this car on my drawing, and what happened in the background is that the system immediately created here in pool another vehicle, basically the copy, which is basically copy of this bus, and it's logged because it's used within the car. Within the drawing. So as soon as I will delete it, just to understand the process. So here it's not locked anymore, so I can edit it. Yeah. So. And here there is one unit inside. So let's edit this, and I will rename it just very quickly RV AU 2015 recreation vehicle. And here you have different vehicle types. So you can select from the list of vehicles what is the type of this vehicle. So maybe one tip, okay, I will finish with this. So what you can do, you can sort your library based on a vehicle type. So maybe because you are looking for some bus, so you can, what I did, I sorted the entire library based on vehicle type. So I have here all buses. And also, I mean, this icon is also showing what type of the vehicle it is. Yeah. So, and you can see basically I have here backup kind of because I was playing already with this drawing. So I created this recreation vehicle based on bus. Yeah. So this is something what can be what I believe is understandable. So and I said what I will do is. I will put another, basically, vehicle which will be towed, you know, so what I will bring, I will take this passenger, car and trailer, small van, passenger car, yeah. So let's grab this four-wheel drive car. So here, by the way, you have the diagram, and you can just switch, and you can quickly have a look what this look is, how this vehicle look like, and what are some of the parameters of this vehicle. Yeah. So you can basically have a look at it. Me personally, I prefer show only plan view with parameters, and then what I can do, I can just simply drag and drop it over this RV 2015, and you see that immediately I have two units combined in one vehicle. And of course, it doesn't look very nice because I haven't specified parameters, the length of the drawbar, and this kind of stuff. And this is just what I want to show you what we can do and how we can do that. So. Then you can edit entire vehicle, so you can go to edit, or step by step you can edit units. So on right hand mouse click I can go to edit, and what I will do is here in couplings you have rare couplings, and then you can say it can be if it can tow or can be towed. You know, so let's say okay, this only the first unique unit can tow only, and what will be coupling offset? So it will be 2.5 meters. Well, how I came to this 2.5 meters? Here you have information basically and then I know that the length of the of this recreation vehicle is 9.009 minus here 4.4 meters, and minus here is another 2.084. Basically, I'm calculating this length here. So I have here a coupling offset, and so I have here a coupling offset, and now let's go to this second unit. So basically, now the car would be here, which is not, again, very nice. So let's edit the second unit. And here in front axle, so what I will do is that it will be on the drawbar. Yeah, so I'm just changing the type of the front axle, so it will be drawbar. And drawbar length, so let's put here, for example, what I said, okay, maybe 1.5 meter, yeah? So it starts to make sense, so basically now this vehicle is, yeah, something like this, yeah? So then, well, more or less, well, I might be already happy with this. Of course, you can maybe a maximum articulation angle, maybe 90 degrees, it's too much, maybe 45. It depends really then on the parameters of this basically towing system, how it will work. And again, you can find different data sheets for different, this, I believe you call it tow dolly, so you can find it basically on the data sheets, how much it can articulate. So this is something which is quite nice. On the other hand, still I'm not happy maybe with this, you know, if it's in profile, this is something which might be nicer. So let's go back and let's go back to tractor and let's edit it. And in fact, here you have body style. And how vehicle tracking is working here, I will just specify from available styles, different let's say, profile view, which will be later on, you will see in animation how it works, how it will work, and then it will be basically available or visible during the animation. So now I just changed the body style from bus to motorhome, which makes a little more sense. And I start to be happy with this, and let's use it. So as soon as I created some vehicle, now I can go around mouse click, I can drive, and I will use again this auto drive arc, and let's use it. And now just really playing, not really in very detail, so maybe something like this. And just to see the result, so vehicle tracking has a possibility for animation. So I will go here to animate. So let's go to animation. So, and I will basically animate in 3D. And immediately you see what we have created. And I believe right now is immediately clear what happened because I had some profile, it extruded to the width of a vehicle which is specified, you know. So this is how animation is working. So basically from profile, maybe it looks here that there is some spare wheel. On the other right now it's extruded. So this is how really vehicle tracking is working with animation, yeah? But don't worry, later on during the session, I will show you how to really improve this and how you can put your stuff there. So, and then you can drive it, and basically now, just I don't have some very exciting drawing, but on the other hand, you can see I just did two extruded solids that you see that it's moving, and basically now you can see how it works and what you can do with that. Make sense? So basically, very first, very simple one. So we created a vehicle based on combining two existing one, putting drawbar in between, of course, sizes, and yeah, that's it. So this is the first one, and of course, if you go here to this library, so you can see that there are a lot of different other types, you know, so just explore it. There are a lot of nice things which can be used as a start for what it's done. So basically here, for example, it's already prepared. This I didn't do. This is already prepared out of box. So really explore it and you will find quite a lot of interesting stuff. So that's the first exercise. The second exercise is that if you have some data sheets, and I'm referring to data sheets, this I found basically on internet, for example, Volvo FH6x4. So if you have such data sheets with information, what is the wheelbase, front axle, etc., so you can take it and bring it to vehicle tracking, and this will be our next exercise. Basically, we will create a new vehicle based on these information which are in data sheet. And what I want to do, just to give you clear overview before we start, so we will create tractor based on this information, and we will use information for this trailer, again, with information, what are the sizes. Yep. So maybe just to keep up with my PowerPoint presentation. So this is what I was referring to. So basically here you have information about tractor, you have information, and we will basically bring this information into vehicle tracking, and we will basically we will receive something like this. Yep. And second one this will be second unit trailer, and based on this information, again, we will have all this information here. So, but let's start here with tractor. So the next one is let's create vehicle. So I will start with fresh new drawing. And okay, I'll be switching between drawings. It's just easier to keep up. So based on this data sheet, we will create a new vehicle. So let's create a new vehicle, and I can use here this wizard. Let's create vehicle. So let's go with AU 2015, and we will create it as a articulated vehicle. And immediately I can define how many units I will use. I will have 2 units. Yeah. So the next one is because of course tractor and trailer. So number of front axles, you know, so just I will be referring to this data sheet. 1 axle at the front, 2 axles at the end, and of course here are the values which I will be using. So 1 axle at the front, 2 axles at the end, 4 wheels per each axle, and now the front track width is 2.495, and in fact this is the same for the rear axle, 495. Yeah. So just I'm doing nothing else but adding this information to 495. Yeah. Next, so wheelbase. So here I will use a wheelbase which is 3.6, because here this vehicle can have different wheelbase, 3 meters, 3.2, or 3.6 meters. Yeah, so I will use this one. So I will be referring to this column creating this vehicle. And rear axle spacing is 1.37, and again, just if you go here, spacing 1.37, yeah, because this one is in millimeters. So And then it starts to make a sense here, yeah, in diagram. Next one, so steering, so lock-to-lock time. Basically, this is the time, how much time driver needs from leftmost, basically, steering, maximum steering, to the rightmost maximum steering. And so this is usually not part of the data sheets, but basically for the small passenger cars is around 4 seconds, 3 to 4 seconds. For trucks, it's about 5 to 6 seconds, and large and oversized vehicles, it's and overweight vehicles about 8 seconds. So let's put here 6, because of course it makes difference, because if driver is driving his car, you know, so, and he will start to move the steering, and in the meantime, because he's driving maybe 10 kilometers per hour, so there is different maneuver if it's slow or fast, you know. So, and it really depends not only on the vehicle type, but it also depends on the skill of the driver. So this is, but this is value which is important, because then it reflects the steering. Because what I need to say, I will not go right now there, but if you would go to drawing settings, in drawing settings is basically specified what is the speed while driving forward and while driving backward. So of course you can imagine then within 6 seconds, so the vehicle will pass some distance, you know, while driver is steering the wheel. So let's put lock-to-lock time 6 seconds. And the next one is we can use either curb-to-curb radius or wall-to-wall radius. So in fact, in my data sheets, I do have both. I have curb-to-curb and wall-to-wall. Yeah. So now you can choose one of these. However, if you have both information, I recommend to use in fact wall-to-wall, because it's more important, wall-to-wall. So basically what we will use this value, and because this one is diameter, so we will use 8.3, just half of it. Yep. So let's go back here. So wall-to-wall 8.3. And coupling offset, so this is, in fact, a coupling offset is not given for this because it depends on the load which they are using for the particular day. It depends on the trailer, and usually the tractor is not sold together with trailer, you know, so this is something which you should put based on some experience, or basically ask the customer what is the coupling offset. So what I will do, I will use coupling offset 0.3 meters. And overall body length, again, I'm referring to this. So basically overall body length is 7.327. So let's 7.327. So width is 2.495, if you remember from the previous. And then important is also a rear overhang. So basically here what I will do, I will of course calculate it, because I know this distance and this distance. So in fact, in my case, rear overhang is 2.395. Yeah, just adding this information together. And you can add mirrors, so basically you can add here the mirrors, because then of course chassis is wider. And in fact, these mirrors can be set up, I mean the size of these mirrors can be set up here in advanced settings. So I will cover it later on. So, and here, body style. Do you remember when I was changing it from bus to motorhome? This is the same story. So basically, how it will be displayed here, how will be the body style in profile. And here, what I will use is, I believe that what I used is, just whatever. So let's use mobile passenger refuse, no truck, where is truck? I'm blind. Yeah, articulated vehicle tractor, so let's use, for example, this one. Yep. So this is basically the style how it will be displayed in profile. And now, because at the beginning I specified 2 units, so I will move to next units. Well, not yet, there is still a cap, so basically what is the size of this one. So you can still play with this one. And in fact, this one is more for aesthetic reasons, because this is not something which will really have influence on our analysis. But okay, if you have this information, you can add different sizes. And then, as I said, we are moving to the next unit because this is the trailer. So in fact, where I'm moving to define this information about the trailer. So let's go here. So number of rear axles are 2. The overall rear track width is 2.55. Yeah, well, and again here, based on this information, yeah, rear 2.55, for example, yeah, total width. And yeah, let's move a wheel on each axle. 4. Next, so wheelbase is 8.2, again based on the data sheet, and rear axle spacing is 1.81. Just again, 1.81 is coming from here, axle distance. Yeah. Oops. And next, so coupling offset is coming from the previous one, so it's copied, and articulation angle, let's keep 90 degrees. And overall length is 13.35, width is 2.55 because this is the width. And you can see immediately system is creating for me this rectangle, and rear overhang is 3.7. In fact, this information 3.7 is not given, but it must looks reasonably, because in fact right now it doesn't make too much sense. I was talking about the cabin size, and now it would interfere with this one. So you must be a little bit careful with this, you know. So if I put 4.7, maybe it makes sense, maybe not. So this is something which you should investigate, that these 2 units fit together. And again, body style, so how it will look like in profile. So there is a lower trailer unit somewhere. Again. Yeah, somewhere low boy trailer, yeah, something like this. No, this one is not very nice. So basically, this is just, again, this is for aesthetic purposes, in fact, yeah. So low the trailer. This one, for example. Yeah, this makes more sense. Yeah, but again, you will see later how you can create this one based on your requirements. And yeah, I'm happy with that. Let's finish. And then you can use it. So basically, again, how to drive arc, and yeah, I will just show quickly. Don't specify anything else, and just animate it. Yeah, so we have just created this one, and you can drive it. So just we have created this one, but now let's go further, because I was talking also about rear steering. So now, if I'm using this vehicle, there is no rear steering. Basically, the rear axles are fixed on the trailer. I mean, of course, this is not a correct example, because these are really bigger one, but I will use this one just to explain you how it can be defined. So if I go back to my here, so what I can do is I can edit this one, and there is rear axle, and what we can do is we can define rear steering, but of course not with fixed axle. So what we can do is we can use, for example, boogie common axle pivot, and then my rear steering is enabled, so you can see it. So basically, based on type, you can use different steering, and then here, what I have possibility to define rear wheel angle, because it can be overridden during the driving time. So basically, either it is linked to this to the articulation of the tractor, or it can be in fact overridden during the driving. So what we can do is we can add information, and these information are, I believe, yeah, this is, again, I'm not keeping up with my. So here, what I did is I did this generic tired boogie wheel second steering, yeah. And the next one is that I can specify here this rear axle is linked with the front angle, yeah. And then I will specify maximum secondary steering angle and lock-to-lock time. Again, how much the driver at the back needs to change this steering from leftmost to rightmost steering. So let's define it. So 30 and 8 seconds, 30 degrees and 8. So, and now, if I start to use this vehicle, which I have modified, now what I can do is, if I start to move my mouse wheel, so you can see that I'm overriding this rear steering, yeah? So based on this, of course, but I can go here on this slide. So basically, I am defining what, let's say, the rear axle on the trailer will do while turning, yeah? So, and of course, it depending on this, you will see different results, yeah? So, make this one sense, and of course, what you can do is this, because I immediately switched rear steering on, but what you can do is you can just link it, sorry, here, edit. You can just link it, and you don't have to enable it, yeah? So in this case, it will be linked together with front steering, but it will have independent boogies anyway, yeah? So, let's move on, and having that, maybe you want to add some load to your trailer. Sorry, to your trailer. So what I will do is, in fact, I will use the same one, and then I will go and edit it, and now here it is what we'll be using, body outlines. This is where we can add different parameters for this trailer, in my case trailer, because I'm editing the second units, or of course for the tractor as well. So what I want to do is now, while I was defining this trailer, we specified this, in fact, rectangle for analysis, yeah? But what we can do, we can add load, yeah? So I will add a new load, so maybe we will be transporting some wing, yeah? And then you can specify what it will be, if it will be a rectangle, line, circle, so you have different stuff what you can do, or in fact, you can and you will see it later, we can add even different information. But what I want to do is now I will use this rectangle. And well, I prepared just some example how it can look like. So length will be 15 meters, offset -1 meter. You will see how it will look like immediately. The width will be 3 meters, and front radius will be, so you can immediately see I'm creating this for load, 1.5 meter, and wing radius, I will specify, for example, 3 meters. So I just specified load, which will be used for analysis, because of course, if a vehicle is turning, or better said, trailer is turning, so this will affect the step path analysis. And just to show you what you can do, you can add some user-defined. So what I will do, I will add a new text, for example, and you can add text and let's say Autodesk. So I just want to show you that there is more information which you can add and which can be later on analyzed. And while I am having something like this, so let's do this. So let's drive this vehicle. And you can see that I have immediately, well, in fact, more information, because there are, let's say, basically where is the extent of chassis, or there is also extent of my wings, of my load, which is on the trailer. And if you have something like this, what you should understand is you can modify, because this is what we call reporting. So if you go here to properties, in properties, I can specify different reports, and now it's up to me what I want to see, what I don't want to see. So basically, do I want to see annotation, user-defined, and stuff like this? So basically, all this stuff I can do. So load, so what I can do with load, I can edit this, and I can say, okay, maybe make, fill or envelope, and I will hatch it, for example. And immediately, this is how it will look while driving. And again, something like this I can change for one vehicle, but if you go to settings, drawing settings, we have this possibility also here, so you can predefine it for entire, for each and every step path which you will define within this drawing. So you can predefine it. So just understand what are the possibilities. We are adding the load, and then within the analysis, I will see the results immediately, so how it's affecting my, my stuff. So, makes sense? So with that, we did rear steering, and let's move to next topic, which I want to cover. Here are just different, comparison. I put here comparison, how it will look like if there are fixed axles, linked axles, basically if this rear axles are linked with the front steering, or if it's independent. So basically then you can do different stuff, and you will of course receive different results while making this analysis. And then we define this load, so just to keep up again with my PowerPoint, which of course will be uploaded to AU web page. And we created a report, so I just showed you what we did. Now let's move to the next topic which I want to cover, animation. So basically, I showed you that within the profile you can specify something, but there are some limitations because there are some there is stuff which is already there. However, for animation purposes, then if you are animating, you can create what you want. And my example is that I have some prefabricated, for example, abutment. By the way, it's coming from Revit, you know, so I just, as an exercise, I brought it from Revit. I save it, convert it to DWG file. And now I want to show you how you can add this information on your trailer. Then you can drive through with your vehicle. Yeah. So let's do this. So I will open my drawing where I have it already, because I just don't want to go to Revit and show you all that stuff. So what I have here, and I want to explain you what is important while creating something like this. So I have here this abutment, and if I look at it, so it's nothing exciting, but makes sense. Yeah. So, and this one we will use for our animation. So what I will do, I cannot just add something on the trailer. So basically, I will have to create trailer plus the load for animation. So for this reason, I will create rectangle first, and I will make dimensions. So basically, this will be my size of my trailer, 15,000 and 2,500. So the point is that this drawing is in millimeters. So right now it will be 15 meter long and 2.5 meter wide, this trailer. Yeah. And the next step which I will do is I will extrude it by ½ meter. Yeah. And now what is important, if you are creating some block which you want to use within vehicle tracking for animation, it must be in this direction. I mean west to east. Yeah, this is how it works. So this is also the reason what I will do with this block. I will rotate it. It's not in fact blocked. It's not blocked yet. Rotate. So what I will do, I will rotate it to have it in the same. And then, as I said, I have to do it as one block. So what I will do right now, I will move this part, and now I will just snap to midpoint here, and I will move it here. And now, this one I can use to create block. So, whatever is the name. So I will pick the point, and I will pick in this coupling, where is the position of the coupling, and it will be this midpoint, yeah? And what is important here is, if you would do something like this, it would basically be on the ground. However, don't forget that there are tires. Depending on the diameter of tires, my trailer and load must be above these tires. So then I have to move the value to minus 0.9 meters. Yeah? So basically, I have to move it up above my wheels, above my tires. Yeah. And this is in millimeters, and of course I should select the object. Yeah, because in fact when I was moving it from Revit, it was in millimeters, and now I want to have it in meters. So. And the story is that if you will create something like this, then it's very easy. If you go to your vehicle, and I have here this pool of the current vehicle. So now what I can do for the trailer, if I go to edit, in fact, it is not so important, because anyway, if I will specify this block, it will override this body style. But what I am usually doing is I am doing like unspecified body style that I know, okay, the shape of the trailer is specified here, but again, it's not important because it will override automatically. And here, what you can do is you can use this body outline side elevation, yeah? And basically what we can do here, we can use basically our 3D block, which I have just created, yeah? Makes sense? And then if you use it, oops, sorry, mistake, so now I want to drive it, of course. Just to show you what we have just created, nothing. Oops, so, okay, I used wrong, obviously, no problem. I used the wrong block because I was, as it seems, talking and not thinking. So what I will do is, again, editing, and trailer road. Well, good point. I don't remember what was the name. But just to give you idea how it works. Yeah. And I didn't specify properly this elevation. Yeah, because it was in what I did is stupid thing. I was mixing millimeters and meters. I put 0.9 as a meters, but it should be minus 900 millimeters. Yeah, when I was creating this block, because right now happened what I just said, because it's in fact it's sitting on the ground, and I don't have this tire width. Yeah. So I was talking about this, but I didn't consider my units, change of the units, yeah? But then you can see that you can do something like this, and you can create your own load for animation. And just to give you more ideas what you can do with this is, I will open another drawing, because since 2016, what we can do is we can combine, in fact, or we can upload, come on, baby. We can create, or nice one. What is the problem on my computer? I don't know. I just wanted to show you this one. Just what you can do in fact, don't forget in 2016 what we can do, we can use reference as a Navisworks model, and in fact then you can drive on the surface of your road created, for example, in Civil 3D, but around you can have Navisworks model. Yeah? So basically, what I just wanted to tell you is that you can in fact animate within a kind of Navisworks model, because you can reference it. Yeah, so then it gives much nicer results or nicer options. What I want also to mention is, and this is I would say quite important, is that if I would open right now new drawing, what we can, within vehicle tracking, what we can do is functionality that we can basically save this as a library. So basically, because you are creating your vehicle and you want to share this vehicle with somebody else, because you don't want to have it only on your computer. We can do this. One important note here is that this block will stay in your drawing. Be careful with this one. So basically, what you have to do is you can supply other person also with this block. Otherwise, he will have only trailer, not this abutment on the top. Yeah? So basically, if you are saving as a library, this 3D block is not with this, only name, in fact. He will see that the name, he will say that this trailer and abutment, whatever it was the name for this 3D block, but physically, he will not have it. Yeah? Use right block and give him this block. Otherwise, it will not work. Yeah? So, this is as far as animation is concerned, but also this is what I call it. What we can also do is we can create basically presentation vehicle. So of course you can make 3D block and stuff like this, but we can do even nicer block. And here is example that you can create vehicles. And I will show you example coming from 3ds Max. Yeah, so basically you can have vehicle, you can download it maybe from internet because there is a lot of libraries of such vehicles. And I just want to show you how you can bring this vehicle or this shape into the vehicle tracking. Just for information, these pictures here are pictures of presentation vehicles which we are supplying as a, in fact, subscription benefit. You know, so if you go to your account, you can download this one. But this is something which you can do. Yeah. So basically, 3D presentation vehicles, and we are supplying you with such vehicles like this. What I want to show you is that we will bring in something like this. Yeah. This is some vehicle in 3ds Max. So do I have it? Yeah. I don't have 3ds Max. Should be. Again? Yeah, you can put there whatever you want. It's up to you because you are specifying the sizes, basically parameters of this. So example here is that I have in 3ds Max such vehicle, and then how to bring it to for animation or presentation purposes in vehicle tracking. Of course, here what you should do is you have to export it to DWG file, first step. And also what you should check here is what are the units, yeah, in 3ds Max, if it's created in millimeters, meters, feet, whatever, yeah? So, and this one is created in meters, just that you understand the units. So, and then, what I will show you is, you can then use it here. So my goal is to open another drawing. And basically, after exporting this 3ds Max file into the DWG file, I obtained something like this. And again, the same story like we were doing animation. First, I have to rotate this vehicle west-east direction. So basically, what you have to do is to rotate, and yeah. What I will do is rotate this point will be just here around this point, and I will rotate it like this. And then the similar story. You have to make basically a block out of it, yeah? And what you, where should be the point, insertion point should be front coupling. So basically, what I will do, I will pick here the nearest point here. And again, so depending if your units are meters or millimeters, this I checked, so it's in meters. So you have to put block name. So select the objects which you want to convert, and you will create block out of it. Yeah. Few things which I want to tell you is, you will see it later on. In fact, what I would recommend, later on you will see why, don't create this presentation vehicle with wheels. Because in fact, wheels are kind of supplied by vehicle tracking. Because vehicle tracking will automatically add these wheels. And of course, the reason is because steering, yeah, that is not static. It can be front steering, rear steering, and stuff like this. So basically, my suggestion is don't, just delete these parts and create basically a vehicle without the wheels, because then here is my block. And then, of course, now we are combining, in fact, two things, because we are having this here, as I said, insertion point is here in this front couplings, yeah? And then what you should do is, and now I'm here in this drawing, I created recovery track. Now I will not do this, but just for your information, I created from the data sheet, basically, I created this recovery track based on information, what is the size, because don't forget that there is this towing system, so I created this that it is based on the information as this real recovery track with all sizes, yeah? So just here, the profile is, let's say, a wrong one, because anyway, at the end, we will replace it with this 3D block. But important is that you are really creating, with all information, what are the wheels, what are the size, what is the width, and all that stuff, basically, as we were doing it during the first exercise, you are creating exactly the same. And the information are, in fact, in my case, sorry, stupid me. In fact, just that you understand, yeah, all this information are coming from basically measuring what is real size of this vehicle. And at the end, now I will go to body outline, and now I will just bring this 3D block which I created, yeah? Hit OK, and now let's try to drive it, that you will see the result. Yeah, and this is my vehicle, and now I can drive it. But as I said, I would strongly recommend, if you look here, yeah, because in fact I have double wheels, in fact, yeah, one coming from my 3ds Max and this block, and one supplied by vehicle tracking. So this is why I strongly recommend just first delete these wheels, and then it will look okay, yeah. So, and then, of course, you have proper size of your vehicle for analysis, but also for the animation, it looks nice, yeah? Because it's based on really nice vehicle coming from 3ds Max. So, and let's move forward. This is what I want to cover with sweep path analysis. And let's have a look. I want to give you a few hints and information about roundabout design. Because roundabout is not difficult, but again, you should understand, I believe, a few things. If you are doing roundabout design in vehicle tracking, yeah, let's go to roundabout. In fact, you can make your roundabout based on polylines. Because, as I said, you can install the vehicle tracking on the top of AutoCAD, for example, So there must be some functionality for this. But in this case, of course, we will not be able to create corridors. We will be able to work with alignment, profiles, etc., etc. One thing what you also should understand is that if you think, okay, I can start with polylines and then I will convert it to alignment, because we can do this, of course, in Civil 3D, then we can create profiles. Yes, you can do this, but the point is that if you will create a roundabout based on polylines, and I will show you quickly what I am talking about. So I will do quickly a roundabout. So in fact, I'm creating just quickly geometry, so creating a roundabout. Then, of course, later on, you can convert this one to alignment, etc. The issue is that if you go to edit your roundabout, you have no possibility to specify here, for example, profile, yeah? And you cannot change that how it was created. You cannot say, okay, now I want to replace these polylines with alignment. So basically, if you want to use, let's say, full advantage of basically a junction design, so what you should do is you should start using basically here I have drawing with alignment and profiles. Yeah. So now I have while creating my junction, let's create this roundabout. I will use the same roundabout, basically some US urban single lane roundabout. So I will say, okay, existing surface is this one, because I have at the background existing surface. Now I can specify if I want to use layout profile, existing ground profile, existing surface, etc., etc. So basically, you have basically this capability here. System is by default picking up really designed profiles. Yeah. And now, in my settings, I said, okay, I don't want to create corridor. Basically, now I am just creating shape of the roundabout, and now I have full capacity, you know, just to change where it will be, how it will look like. Now I want to give you some hints, you know, how it works and what you can do with this. According to my opinion, a very nice function is, if you go to edit this junction, you can go to roundel, and here you have level and grade. So basically now this information has been taken from existing surface, but now what we can specify is overall crossflow. Basically I can tell to system how the roundel will be shaped, sloped, better said, you know. And if you are familiar with Civil 3D, in Civil 3D you would have to make some temporary surface, you know, and then use this temporary surface. Here, basically what you can do is just simply say, okay, now I want to have 2% slope. And in fact, what you can do is you can very easily modify even the direction of this 2%, just simply grabbing, changing the direction, side, you know, just moving it. It's just 2%, 3%. Basically, you can type it in. You don't have to type it in. So basically, there is a lot of functionality behind. Another thing what I wanted to talk about a little bit is how it works, because here we have a lot of new elements. There is this junction, but also at the background system is creating alignment, profiles, and all that stuff. What is important to understand is that within drawing settings, you have, if we are talking, and this is something which you should know because it's a bit difficult to understand why it's here, you have styles. Normally I would expect it in junctions, but no, it's in styles. And within these styles, you have different junction styles. But if you hit edit, here it is written how the junction layer will be named and which elements will be stored in which layer. This is quite important, yeah? And there are different things, and just if you explore it, layer, if you go here, of course, you can switch on, switch off different layers. But what I want to give you some warning is, you have here also some lineage, basically horizontal, sorry, stupid me. You have layer called junction 1 lineage. So it should contain the horizontal lines like horizontal markings. It's empty. It is something, it took me a little bit, so this is why I'm telling you how it works. Because by default, don't ask me why, you have here in junction road markings. And by default, solution provider is Line Design Pro, which is some UK-based software which is making horizontal marking. If you want to see really the marking, what you should do, you should switch to vehicle tracking, and it will give you information, yes, but you have to update your junction, okay. And then basically what you have to do is just to go to the properties, and then it's updating everything, close, and then the lineage is there. Yeah, just otherwise this layer is really empty. So this is something what you should be aware of. Another things are, because if we are dealing with roundabout, there are not only like alignment profiles and all that kind of stuff, but also there is a lot of other nice information, like, okay, here are some traffic signs and all that kind of stuff. It is based basically on a roundabout style. And in roundabout styles, if you go to the Explorer, basically what you can do, you can check and view it. And basically you have road markings. Yeah, sorry, signage, sorry, here. Yeah, and here is written, okay, which kind of, basically, which traffic signs are used and how they are used. What is important to understand is that there is, in program data, Autodesk, vehicle tracking, library, there is signs, there are signs, subdirectory signs, and here you have, for each sign, you have 3 different files, yeah? And in fact, I will post it also on Autodesk University webpage. You can customize it. This is something which you can do. It is not difficult, but you have to understand few things. The first is that you have, for each sign, you have 3 different files: JPEG file, info file, and DWG file. DWG file is really just a DWG file with your front sign, basically how it looks like. Maybe it's just like this, that I'm not talking about something which you don't see. So basically, I will just grab one of these. Yeah, it is just sign like this. And out of this, what you should understand is there is, you can make this DWG file in feet, in millimeters, in meter, doesn't matter. What is important is aspect ratio, basically, width and height. And then out of it, you have to create also a JPEG file. So basically, in the same directory is just the JPEG file. Yeah, the same one. And then you have to have also info file, which is ASCII file, just giving the name and also sizes, how it can be displayed. And then you can save these 3 files in this directory, and then you can bring it to your roundabout style. Yeah. So this is something. Yeah, you can see this is coming from Germany, for example, whatever it means. So something like this you can create based on your standards. What is also talking about vehicle libraries? Here you have assemblies, because what you can do is, if I go to my roundabout, now what I can do, I can edit my roundabout, and what I will do is I can create corridor. So in this case, system will create corridor, and system is working. While it's working based on these sub-assemblies. So basically, system is importing these sub-assemblies into the main drawing, and now you can see it's building corridor here based on these sub-assemblies. Which means, of course, again, there are some sub-assemblies, but you can modify them. So basically, what you can do is you can edit each and every DWG file, because there is nothing else but one sub-assembly, one assembly inside. So basically, if I look to this drawing, for example, so there is assembly which will be used to create my corridor, for example. And of course, I can modify it. It's up to me how it will look like. So you can add maybe sidewalk, maybe different curb. It's really up to you. But basically, the important thing is that it has to be named the same way, and the assembly should be also named the same way. Yeah, just modify this assembly and keep the rest the same, and then it will work. One warning, and this warning is, if you will create the DWG file and you will create corridor of roundabout for the first time, system is bringing these assemblies inside. And then even if you delete all assemblies, if you delete everything, and you will modify this drawing with assemblies, it is not updated, this drawing. What I want to tell you is that it is stored somewhere in file, most probably, I don't know where because I'm not a programmer, but if you will modify the source assemblies, but you already created roundabout before it, so it's not updated, yeah? So basically you have to create fresh new drawing, and then these assemblies are imported to this new one. Yeah, this is something to be aware of. So, and there is talking about basically libraries here. Yeah, there are these signs and also lineage, basically this info file, how this horizontal marking will look like, but these are just simple info files. So, and then everything I wrote, in fact, here in this, talking about roundabout, yeah, signs, assemblies, basically how it works. Everything is mentioned here in, basically, in this PowerPoint. What you also have possibility to specify design vehicles. Design vehicles are used while roundabout is created for checking if these vehicles can pass through this roundabout. Yeah, this is, and you can again modify your style, and you can add new, basically new vehicles based on the libraries of the path analysis. And this is something which you can modify, but in the meantime, what we have here is this roundabout. And now, if you have roundabout like this, you have also here design check. And if you click on the design check, the system is giving you information what's going wrong. If, for example, this design vehicle cannot pass through this, it will be written here. Yeah? Or here, there are some settings that system is checking the speed, how it's how a vehicle is coming. So here it's too high speed, so system is just giving you information that you should maybe modify the geometry of your roundabout just to fulfill the requirements. On the other hand, talking about design vehicles, now I can use normal vehicle library explorer, and I can bring, for example, whatever, for example, this bus, and I can bring it to my, sorry, of course I have to drive it. So let's drive it. And now you can see that system is automatically placing this vehicle to this roundabout because system is automatically snapping to the object, and he knows about the fastest about the fastest track, how the vehicle should pass through my roundabout. Sorry, so now rebuilding my corridors. Don't understand why. And now I don't have to do too much. I will just click start point and end point, and system is automatically finding optimum path, yeah? So I don't have to pay attention to this at all, yeah? One information, if your vehicle is not snapping to the object, it is due to fact that here in drawing settings, I believe, you have for no, okay, it's in system setting, path, auto drive, yeah. You have to snap to vehicle tracking object. If this one is switched off, this vehicle is not snapping, just this something which is, I believe default is, if after installing vehicle tracking, is not check this box, so something what you should be aware of, yeah? And maybe last thing before we finish, don't forget, right now my roundabout is in 3D, but my swept path is in 2D only, yeah? What you have to do is, because if you want to make animation, of course you want to see your vehicle driving along the corridor. What you should do is, first thing is, because this is normal AutoCAD Civil 3D functionality, you have to create surface. From the top links, I will create boundary very quickly. So basically, I will create surface on the top of my roundabout, yeah? And I will not display it because it's not important. So, but I need to have this object. And now, if I select my vehicle tracking, swept path, go to properties, you should specify final surface, this junction surface, and I want to project my swept path to this surface. And now you are ready to do animation on the top of surface. If not, my junction is here, and my swept path analysis is here, talking about elevations, yeah? And also, if you want to make a nice visualization, it's also related to roundabout, because now I have corridor, but all these links, all these traffic signs and everything is in 2D only again. So what you have to do is, you have to go to edit your roundabout, and here you have final surface, junction, and project it to this. So now it will automatically bring all my signs, all my markings, everything to 3D. You have to do this. Because, of course, the process is, first you have to create corridor, from corridor you have to create surface, and then you can bring this stuff on the top of this surface. Yeah? And then you are ready to go, and everything is in 3D, and if you go to make animation, whatever, you can do this. And of course, you can use what we did in the previous exercises. You can bring this recovery track, for example, this nice 3D vehicles to be driven on the top of this surface. Yeah. So then if you go to animate, if you go to 3D, so yeah, it will take a little bit time because my graphical card is about to die, I believe. I had some problems by flying here, so I just didn't touch this computer. But now you have all this information. I didn't show this 3D. Yeah, but now I have this vehicle on the top of this roundabout, and everything is in 3D. So with that, in fact, yeah, I finished about the right time because this is what I just wanted to show you. So thank you. I hope it was useful. I didn't want to make, let's say, the class which would be very basic. On the other hand, I wanted to start really with something elementary and then build on this information. I hope you found it useful. Of course, I am here to answer your questions. What I would like to ask you also to give feedback about this session. And with that, thanks for attention. And if you have any questions, I'm here. Yeah. Have a good day.